Hi guys, long time no see. We are going to work on part 2 of lesson 2, simplifying radicals. Our goals today are we're going to be dealing with simplifying radicals that have products and quotients. So there's going to be some division. But we're going to start off with products, and we're going to deal with word problems. Yay, everybody likes word problems. So we've got a door's height is 4 times its width, W. And we want to know what is the maximum height of a painting that will fit through that doorway. So let's always start when we have a word problem by drawing a picture. So we have our doorway, and the height is 4 times its width. So the height is 4W, the width is W. And we want to know the height of a painting that's going to fit through that doorway. Well, we can hold that painting at an angle as we go through the doorway. So our height of our painting is going to be P, and that's going to be the hypotenuse of a right triangle going through our doorway. Yeah, everybody remembers that. So we want to know P squared is going to be equal to 4W squared plus W squared. Now,
Chapter 7.
Yeah, Chapter 7 still here. We've got P squared is equal to 16W squared plus W squared. And so to find the value for P, we're just going to take the square root of, well, combine like terms first. 16W squared plus W squared is 17W squared. Now we take the square root of both sides, and P is equal to square root of 17W squared. Well, W squared is a perfect square, so it'll be W times square root of 17, just 17. And that is our simplified form. And if you know the name of that movie in the picture there, write it down in your notes. Alright, next up, we've got a boat has traveled 3 times as far due east as it did due south. We want to write an expression for the distance the boat would have traveled in a straight line from its starting point to its destination. So we are going again for that hypotenuse of a right triangle, since our cardinal directions are right angles for each other. That's a sailboat.
What letter is that?
That's a D. So D, the distance squared, is equal to 3x squared plus x squared. Don't forget to distribute. Don't forget your squared sign and the D. So D squared, combine like terms, 9x squared plus x squared, they have the same base, we can combine them, 10x squared. Take the square root of both sides. The distance is equal to x times the square root of 10. And fun fact, our 2 little pictures here. The top one is a replica of the Santa Maria, and the bottom one is a replica of a Viking longboat. Those were both built and sailed to Chicago in the 1893 World's Fair. So just random fun history fact.
You're such a social studies guy.
Yeah, I love history. Alright, problem 5, simplifying fractions with radicals. So we've got radicals, we've got chapter 7, and then everybody's other favorite topic, which is fractions. And we can do fractions the same way as we deal with multiplication. We can separate those into 2 separate radicals. So the square root of a over b is equal to the square root of a divided by the square root of b. So we separate them out, and then we can take the square roots of each independently. So the square root of 144 over the square root of 9, those are 2 perfect squares that you should have memorized at this point. The square root of 144 is 12, the square root of 9 is 3. Make sure we are reducing as much as possible, so it is 4.
Do you want plus or minus, or does it matter?
We can just go with the positive.
We can just take the positive?
Yeah.
Okay.
Okay. So we've got the square root of 121 over the square root of 81. Square root of 121 is 11. Square root of 81 is 9. Those are perfect squares you should remember. Now we threw some variables in there, so we're taking the square root of 27x to the 5th over the square root of 48x so we can do our factor trees. We've got 27 broken into 3 and 9, which is 3 times 3 times 3. So we've got 3 times the square root of, well, it's 3x squared times the square root of 3x. 48 breaks into 6 and 8. Four breaks into 2 times 2.
That's what I meant.
So we've got 2 sets of 2's that we can take out. And we've got the square root of 3x. So we've got 3x squared times the square root of 3x over 4 times the square root of 3x. Hey, that's the same thing on the top and the bottom. That can cancel out. We are left with 3x squared over 4. And there's no need to do any kind of decimals with this. Just leave them as fractions. All right, letter D, we've got 144y cubed over 169x to the 4th. So we're looking to take the square root of each of those. 144 is a perfect square, we know. That is 12. And we've got y cubed, so we can take one y out. And we'll be left with a y on the inside. So square root of y. Over 169, another perfect square. 13, x to the 4th. Perfect square is x squared. And that is our simplified form. Our variables are different, so we can't do any simplifying with them. Our last part of the notes for today is rationalizing denominators. What rationalizing denominators means is that we are going to remove a radical from the denominator of a fraction by multiplying both the numerator and the denominator by that same radical. So we don't like having radicals in the denominator. It's annoying. So in order to get rid of the square root of 3, we need to try to multiply it by something that's going to get rid of the square root, and the only way to do that is to multiply it by itself, which is the square root of 3. So we do that to the top and the bottom. We're only multiplying in reality by 1, so our equation isn't changing. Square root of 3 times square root of 3 is just going to be 3. And we've got the square root of 2 times the square root of 3, which is the square root of 6. And that is our simplified form. We do not like radicals in our denominators. So we've got the square root of 18m on the bottom. We're going to multiply both the top and the bottom by 18m, square root of 18m. That's going to give us 18m on the bottom, and it's going to give us 90 on the top, 90m. And we can simplify that a little further. The square root of 90m, 9 is 9 times 10. So we get our primes. We've got one pair of 3's, and we've got the square root of 10m. So 3 times the square root of 10m divided by 18m. Can we reduce that any further?
No. This is underneath the radical.
But can we reduce things outside the radical?
We can reduce things outside
We can!
the radical.
Yay! So 3 divided by 18, we have the square root of 10m over 6m. Okay, so make sure you look at those coefficients that are on the outside to see if they can be reduced at all. Okay. Letter C, we've got the square root of 7x over 3. So we're using our rules. We split that square root of 7x over the square root of 3. So now we just need to multiply both the numerator and denominator by the square root of 3. And we're going to get the square root of 21x over 3. And that's as reduced as we can do because we've got 2 primes in our numerator, and that's as good as we can get. Letter D, square root of 21y cubed over 5. We can break that into our 2 parts, square root of 21y cubed and square root of 5. We're going to multiply by square root of 5 in the numerator and the denominator. So we're going to have square root of 105y cubed over 5, and that can be reduced to y times the square root of 105y. And the reason we can't reduce the 105 anymore is when we break it down into its factors, it becomes 7 times 3 times 5. There are no pairs of factors that we can pull out, so that is just going to stay 105. So just because they're big numbers doesn't necessarily mean that we can pull a factor out from them. They don't always have nice perfect squares as their components. And that is it for lesson 10-2. We will see you in class.